Since the birth of computer science, much has changed. Languages have evolved, and complexity has been abstracted by programming languages and frameworks. Metrics say that projects cost the same, take the same amount of time, and many still fail before ever reaching production stage. Why? Three main topics. For one, functionalities exploded in richness and complexity, allowing for a much richer user experience. Two, the large amount of code needed to develop even the easiest function. And last, the abuse of code reuse and layers. With such challenges came solutions such as microservice architecture patterns, DevOps, and more recently, single-page applications like those built in Angular or React. Each lesson learned from the history above led to a new layer in our applications, yet no revision was made to remove obsolete layers. Modern frameworks implement data layers that obsolete those we had to build. Presentation layers are abstracted by the same frameworks. An exposed web service is just a regular class where business logic can be defined, decorated with an attribute. There is no more presentation layer code to be created. Defining these layers has no added value. As a baseline, only 4 components are now needed to develop an application screen in an Angular app, for example. An HTML view, a TypeScript component class, a Web API controller, and the data objects to be shared between client and the server side. This is the current baseline effort to develop a functionality, yet our projects show a very different baseline of code journey. It's time to review our architecture designs and to remember that framework vendors relieve us from the dangers we faced in the early years. Things evolved, so should our design methodologies. In a quest to bring development closer to the baseline effort, the following drivers and principles are crucial. 1. Reuse functionality, not code. 2. A system should be composed only of components that add real functional value. 3. All system folders and components should be functionally organized. 4. Hiding or moving code doesn't make it disappear, only makes it harder to find. It's easier to create, maintain, and read sequential code than code split all over the solution. 5. All functional code should be visible as closely as possible to the origin of the functional problem itself. 6. The only code to be abstracted from the component above is one that has no functional relevance. 7. Avoid functional code abstractions like validate methods. Any rules, validations, or ifs needed to comply with the functional requirement should be visible soon and follow the rules above. And last, only promote a layer to a tier when no other option exists. These principles by themselves will create a low-code system, which is a mindset and a methodology rather than any product or technology. I ask you to imagine the following: a world where functional teams define application visual and data model in an intuitive and direct fashion. This application model is used to generate the skeleton of the application, and that code is the absolute minimum code to solve functionality. Easy to read, just standard Angular C# code, representing the baseline components of a single-page application, with the basic deterministic tasks like HTML database queries and data objects. Imagine that developing a production-ready system was just developing the customizations to generated code. This way, user experience teams can customize user experience just by applying customizations to the application design system. This brings people skills to use in what really matters, in the real functional challenges of a system, in the complex algorithms and interactions rather than brainless time-consuming tasks like copy-paste 100 fields on an HTML page or data object. This is the world of low-code frameworks, and it's a reality.